Imagine the possibilities. All of them. Now test them. Improve them. Make them real. Impossible? Not at Altair. That's because we're in the possibility business. Since 1985, we've been quietly creating the tools that enable visionaries to transform impossible into reality at market-defining speed. Best-in-class design and simulation, enterprise-grade data analytics and AI, turnkey high-performance computing. Now, as the only company bringing these technologies together, seamlessly merging data science with rocket science, we're setting the pace for a bold new standard of innovation. This is the science of possibility, where we can envision a better, smarter world and then bring it to life, faster than ever imagined possible.
Will be a little bit quick, right? But I just want to show you all the steps of how to actually use physicsAI. And then later on, you can try it with the exercise that I've shared to you, right? So make sure that you can click on the link. If you cannot click, if the link cannot be downloaded, just let me know, right? So I will be starting on the session. So you already know who am I, so I will not skip that. So basically what physicsAI is one of our newest tools to actually train an AI model. Once the AI model is already trained, you can actually use the AI model to actually predict results. Okay, so if you already have a trained model, then you will not be using your original solver anymore. Okay, so the purpose of this is to actually replace the solver so that you can get results faster, right? But it's good. You probably may not know with AI models, there is a certain degree of accuracy that we can expect from training AI models. So at best, you can use this as a fast prediction to understand how your design will work, how will it perform, but never take this as the final result. We always need to run the solver just to verify later on. Okay. So the purpose of today's session here is to learn how to use HyperMesh. Okay, so the physicsAI model or the physicsAI feature is actually embedded in the new HyperMesh, and you will need to actually install the latest HyperMesh to actually use physicsAI. It is available since version 23.1. So if you are using any HyperMesh that is older than that, you need to download at least version 2023.1 or the latest one, 2024. Okay. So we'll go through all the steps, what physicsAI is, what can we do with it, and then how to set up, right? So let's go into it. physicsAI will be using your historical simulation. Result has a data set, right? So whatever simulation that you have done before, whether it is in OptiStruct, whether we solve using OptiStruct, or it is solved using Radios or Abacus or Dyna, it doesn't matter. As long as we can convert those result files into H3D, right? So if you're using OptiStruct and Radios, it is already set because the default results for OptiStruct and Radios are H3D files, right? But if you're using Dyna models or you're using Abacus models, then you need to convert your ODB results or whatever, let's say Nastran OP2 results into H3D first. Okay, means you need to use HyperView to invoke the HV trans, right? HyperView translate dialog box to actually convert all your results files into H3D files, right? And then the H3D files will be used as the data set that we will use for training the physicsAI model later. Okay. So what's the difference between physicsAI and another machine learning product of ours, which is HyperStudy, right? So with HyperStudy, what you would first need to do is you will need to build your variables, right? So you need to actually specify certain values as parameters to set them up, right? So you need to set what's your design variable. And then when you train, let's say you have done a fit, and then when you get the results, or whatever results that you get in HyperStudy is basically scalar results, right? For example, what's my maximum stress, or my maximum or minimum displacement, maximum displacement. So they're all scalar values, and you don't see the contour results. You don't see the stress distribution, right? So that's HyperStudy. You need to set your own parameters, and then the results are scalar. And then when you actually have HyperStudy in HyperMesh, we call it the Design Explorer, right? So in the new HyperMesh, there's one Design Explorer. It is actually embedding the feature of HyperStudy into HyperMesh. And with that, you get the same, you are required to do the same steps of creating your own parameters. You will also do some machine learning in the Design Explorer, but the difference between Design Explorer and HyperStudy is Design Explorer allows you to view the results in contour mode, right? So you can see the stress distribution for the entire mesh instead of just one scalar value here like this. Okay, so that's Design Explorer, which is essentially still HyperStudy in the background. Then we have physicsAI, right? So physicsAI is also in HyperMesh. The difference is when you set the parameters, you don't need to set one by one, right? Because the entire shape or the entire mesh is used as a variable. Okay, so you don't need to go and define that there is a thickness here, there's a variable there, and so on. So every shape in your model is going to be used as a variable. And we actually use something called deep learning here, right? So compared to the HyperStudy, it's actually using machine learning, but in physicsAI, we are using deep learning. Okay, so we call this deep learning model here geometric deep learning. Okay, and once the model is trained, then we can use it to predict on results, right? So when you do prediction, your input here can either be a mesh model or just a CAD. Okay, so you don't even need to mesh the CAD first. If you just have the CAD, you just throw the CAD into HyperMesh, you hit predict, you get to look at the results immediately, right? So that's physicsAI. Okay. At this point, any questions? Okay, so I cannot see the chat, so if you have questions, you need to unmute. So let's go on the process of creating the physicsAI model first. You will use historical simulation data. So these are all H3D files, right? So we can already read H3D files here. So if you have other simulation data, you need to convert it into H3D first, okay? Convert into H3D, and then it will be used as a data set. So you can see here, we have like multiple designs. All these different designs here, they have a H3D file, okay? So in this case, this is a HRED design, which is for a CFD simulation. So they will have results of pressure, velocity, and so on for each of these designs here. Okay, so those are the results for H3D, for CFD, which is then converted into H3D. And we use those H3D here for training. Okay, so you can see here, they are consisting of different designs. You can see here different inlets, different outlets. Some have a very curved member here, some is a very straight channel, right? So you can see here, different designs being used as the data set. Okay, once this is trained, we can then use the physicsAI model for prediction. So you just throw in a new design. It can be already a mesh part, it can be a CAD as well. Doesn't matter because we can accept both, and we can then do prediction on the new design here. Okay, so this is the workflow. we'll go through this workflow together in one of our examples later on. Okay. So the first step, I'm going to go directly on to how you can use it in HyperMesh. Okay. So as I mentioned, you will need the latest version. I'm using 2024 here. physicsAI is available since 23.1. So if you're using 23.0, you don't have it yet. Okay, so you need to get the latest one, right? Or you just blocking. Okay, so now you see that there is no physicsAI ribbon. Okay, here this is a Design Explorer ribbon, which I mentioned just now, which is the hyper study in the background, right? But there's no physicsAI. So what you need to do to enable physicsAI is you go to View, Ribbons, and then you see there is one physicsAI at the bottom. Okay, so then this ribbon will be enabled, right? Just to confirm that you are seeing my HyperMesh and you're not seeing my slides. Can anyone confirm?
Yes, yes.
Okay, good.
Yeah.
Right. So that's the first step, enabling the physicsAI, right? Again, go to View, Ribbons, and then look at the bottom here, there's physicsAI, right? Then this ribbons will, physicsAI ribbon will be enabled. Click on it, and you see there are only 5 icons here. Okay, so it's very simple to use. All you need to do is just work from left to right. You can get your physicsAI model. Okay, so the first step here is to create a project. Now, if you're not familiar with the new interface, let me just brief you a bit. Every icon that you see here, right? Sometimes they are just one, they have only one particular function. Like predict here, there's only one function. Some icons, they will have multiple functions, okay? So to know that how many functions are there, you can just look at the dot at the bottom here. For example, the project here has 3 dots, means that there are actually 3 functions, right? So when you hover your mouse above it, you can see that they're actually pointing to different functions here, okay? Right here, under datasets, there are 2 dots. 2 dots means there's 2 functions. This is the manage dataset, and here is to create dataset. So 2 functions here, right? So you can see by the number of dots at the bottom. Okay, so now let's go to creating a project. First, you will need to create a project, okay? And you just put in the project name. For example, let's say, I don't know, let's do physicsAI. Okay. My project is physicsAI, and most importantly, is to choose your location, okay? Because when you choose your location, everything that you have done, when you read in the data set, when you train the model, everything is going to be saved in this location here. So this is very important because there is no way to actually save. For example, when you have created a project, you read in your data set, there is no way to save this, right? It's automatically saved into this location actually. So there is no need for you to press save when you're working halfway. Everything is saved under this location. So that's why it's important to set where your working directory is, and then remember where you placed it, right? Otherwise, you'll be lost. Okay, for example, I'm going to put it here. Right? So I'm going to select this folder has my working directory. Okay, so that's the first step, putting a project name and then create a working directory and just click OK. Right. When it's already done, you will see that the author here will include the project name. Okay, so in this case, my project name is physicsAI. So you see that this is the project name here. Okay. There's also a way to close it. So if I don't want to work on this anymore, I just close my project. So that's the first step, creating a project. Okay. And then the second step is to read in your data set, right? So it doesn't matter if you have clicked manage dataset, you can still create dataset from here. Hit the plus button and you create the dataset, or you can just go all the way straight to creating dataset with the plus here. Okay. So common themes that we see here is whenever we see plus at the icons, is normally to create. Okay. So normally to create. So let's create a data set. And here we will need to read the H3D files, right? So where are your H3D files? So to get your H3D files, I have shared you two folders. One is 1A, the other is 1C. I'm going to use 1A here. When you look into 1A, you will see that we have some input data, okay? And then there's a test data here, right? So input data has 7 items, test data has 2, right? In this case, we have separated them out so that we are always trained with these 7 data here, and then we'll do testing with these 2 data. But in any case that, let's say if they are placed together, like all 9 of them are in the same folder, then you don't need to separate them, because when you create a data set, you will be able to enable the train and test split here, right? So it's entirely okay if all your H3D are in just one folder. You don't need to purposely separate them out first, right? But in our case here, it's already separated, so I'll remain it that way. So first, you need to read the data set and search for the folder. I am searching for HVAC, this input data here. All my H3Ds are there. And you can see that all the H3Ds are listed down, right? So what you need to do here is you need to choose them to be moved to the right, because only these will be used. Okay, so all these are the H3D listed in the folder. Select all of them and I put it here. Okay, it depends. If you, let's say I just want to use the 5 of them to train, then you can choose the 5. Okay, but in this case, I want to choose all 7, so I just move it to the right here. Okay, and then put a name for the data set, because if you don't put a name, you're going to click OK. Right, so OK will not be enabled until you put a name here. So let's say I'm going to call this training data. Train data. Okay, so the 7H3D will be used as training data. In this case, I don't need to enable this train test split, right? Because I've already separated them earlier. I don't need to then use this one. But if you if all your H3Ds are in the same folder, then you probably want to do this, because we want to separate the training data set from the testing data set, right? So like if I set 80% here, 80% of the training of the entire data set we use as training. The other 20% will be used as testing. Okay, so it's always important to test the AI model, because for all these H3Ds here, we know the results, right? So we're going to use these results to compare with the prediction done with the AI model that we have created. And if the scoring is not good, then we can then choose to train some more, right? Otherwise, there's no way to know whether this AI model that we have trained, it is effective or not, okay? Whether it's accurate or not. So that's why always have some data for testing, okay? In this case here, we have separate data set for testing. So I will not be using, I will not be enabling this here, okay? So I click OK, and then this data set will be read. Any questions?
Excuse me, Raymond. There is a question in the chat from Arnold. Can you see the chat? If not, I will read the question. No. The question is, do all S3D files have to be in the same folders, or can we have them in subdirectories?
Rewrote again, maybe, if you can see. Hello?
Yeah, I
Brian,
think he,
Brian has crashed.
Hello?
yeah.
Hello? Can you guys hear? Am I back?
Yes, Raymond, we can hear you.
Okay. I
Yeah.
don't know why it got crashed. Share screen. Okay. Yes, all the H3D needs to be in the same folder. So if you have subdirectories, then it wouldn't read because it's only one level. Sorry, it will actually read, but then, yeah, it will be listed down here. So if there's a subdirectory, I've tried it before. So if there's a subdirectory, it will also read inside. Okay. So in this case, if it doesn't read, then you need to move them out. Okay. So, but subdirectory is okay. But if let's say it's in a different location entirely, then it's harder. Okay. So at least the parent folder must be the same.
Okay, thank you.
Right. So yes, that is the questions now. Okay, same questions. Okay. So once you have read it in, you see like this here, right? They're extracted, you have 7 files, and then all they're presented here with the nodes and elements, right? And next step, let's do another reading. So I'll click on the plus here, and then I'll read in now the testing data set. Okay, so for me, like if I've already separate them into 2 separate folders, I need to read them separately. Okay, so otherwise you can just enable this one and read everything together, right? So when you actually enable train test split, the files that are chosen to be training, the files that are chosen to be testing, they are random. Okay, so you will not be able to specify like the first 10 is going to be used for training, the last 2 used for testing. So it's going to be random. Okay. So now this will be the test data. And then same thing, just hit OK, and now read the testing data set. So this will take some time depending on how large your model is. If it's a small model, then it's faster. If you are reading a large model and you have more H3D files, it'll take longer. Okay. So now I have 2 data sets. Okay. You can show log as well if you want to see whether everything is read in correctly. If there is an error, it will also show in the log file, right? So then if let's say, for example, you test it on your own data and you see there's error, you can show the log. You can also send us the log file if you want us to see what's wrong. Okay. Now here is only showing the log, right? So where is it actually saved? Okay. So remember the working directory. So if I go back to my working directory, which is on my desktop, here you see under datasets, here you have the 2 data, right? These are the 2 data that I created, train data, test data. Under it is actually the log file. Okay. So if you encounter any errors in reading, first step, you can show the log here. You can read from here. The other method is also to go into the working directory. You see the log files under there as well. Okay. So basically, the data is being read and saved in this PS data. And this is the log file of the extraction used now. Right. Okay. So I have already 2 data sets, one for training, one for testing. So now the next step, after you have done the data set, is to go to the next one, which is the model training. Okay. Again, I'll just hit on the plus button on top. And then here is where I can actually set the parameters to train my model, right? So now this is a CFD result file. So that's why you can see that the outputs here are CFD related: pressure, eddy viscosity, velocity, surface area coefficient, and so on. So all these are CFD related. If your H3Ds are from a structural simulation, then you simply see stress, displacement, strain, and so on. Okay, so it depends on what you have in your output file. Right? Yep. questions?
Sorry, not to interrupt. I'm just writing down my question.
Okay. You want to ask? Oh, you're typing?
Lemon, I don't have the checking box in front of the variable name.
Okay, you just drag this.
Okay.
So sometimes your graphic is squeezed, so just drag it a bit, you see the box there.
Okay.
Right?
Yeah, I see.
Yeah. So so the output is depends on your HVD files. And then the input here will always be the same. You have only two inputs that you can use. One is a CAE coordinate, which should be checked because otherwise there's no point of doing physicsAI. So physicsAI uses the shape of your model or the shape of the results as input. Okay, so all the coordinates, right? The coordinates of all the nodes in your model becomes a variable. That's how we detect this shape from another shape, right? For example, I've changed the geometry. One there's a rib, the other one has no rib. So how does it recognize this change? By actually detecting the nodes, right? The nodes and also the coordinates of all the nodes. Okay, so all the nodes becomes a variable, right? So here, this one should always be checked. Otherwise, there's no point doing physicsAI. And then the other one here, you can see the other variable here is the part label. Okay, part label. So what does this part label refer to? This part label refers to the component name. Okay, for example, in my model, I have components, right? In my model, I have all these components here, right? So in whether you're using OptiShot or Radius, you see components here, right? So the components here will become a variable. For example, in some assembly, maybe I have only 10 components. Some assembly, I have only 7. Some I have only 3. Okay, so the component becomes a variable, right? What's the purpose of this? If you observe that we are actually using here, nodes has shape variables, right? Nodes has variables, right? So if the nodes are variable, if let's say all my models are just skin elements, they are just 2D shell elements, right? How does it detect thickness? Okay, because you can see here, I don't have property thickness. So that means I cannot take the property thickness as a variable. So how does it detect that in this model, my thickness is 1 mm, another model, my thickness is 2 mm. Okay, so the only way that for this version right now, the only way that we can put in thickness as variable is to use this part label here. Okay, so you need to enable part label, and not just that, in your original model, that is before you run your results, your model should be renamed with the thickness inside. For example, this is 1.0 mm. Okay, then maybe I have another model that has a thickness of 2.0. Okay, so that's how we can recognize that they are different thickness. Right? The same thing goes for materials. Okay, so you can see here under model training, there is no variable for materials. So let's say if component, okay, let me rename this. Let's say this is component 2. Okay, so component 1 has a thickness of 1.0, component 2 has a thickness of 2.0. They may be using the same material in this model. In the next model, maybe I'll change them to aluminum, right? So to induce that change as well, you also need to rename or include the name of the material in your component name, like this. Okay, so in this way, we'll be able to recognize that they are having different material as well. Okay, so this is the workaround for now for thickness and material, especially for shell thickness, right? So you need to put it into your component name.
Do we have to set the same ID for the component?
ID not important. It's the
Okay.
component name. Yeah.
Sorry, like is it working like importing every H3D into physicsAI AI, sorry.
Yeah.
And then separating them and assigning them to components?
No. No, you need to set up your model first. You need to run them. And let's say if before running you didn't set the component has set it is, then there's no effect. So we are not changing the H3s anymore. So this has to be done before you run the initial simulation, before you get the H3D.
Okay.
Hope that is clear. Yeah. So before you get your, so let's say if you have already 10 simulation results that you have run before, but before you run that, you didn't rename the component name. That means when you actually check on this later on, it has no effect, right? So you need, unless you want to rerun them again, then you can go and change the component name first. Output has a .fem or .radios to run again to get the H3D, and then you can use this when you're actually training the physicsAI. So far, okay, any questions on the inputs here?
How about the load amount?
Load amount, so in this case, you would want to actually train a physicsAI model that is predicting for a particular boundary condition, right? So in this case, the boundary condition doesn't change. That means your load cannot change as well. But it is also possible that you actually put in the, let's say, for example, the force magnitude in the component name. Okay, so that it recognizes that when I actually look at model 1, right? I have so many data sets here, right? I have so many data sets here. So when I actually look at model 1, when I look at the component, the force here is actually 1000. So this is the, then it will recognize the pattern that the stress result due to this 1000 Newton loading is this, okay? And then when I have another H3D, and let's say in that other H3D, the naming here has been done, the force magnitude here is 2000, then you can recognize that these stress values is caused by a magnitude of 2000. So this is how AI learning is. You need to set certain steps for it to actually recognize the pattern.
Okay.
So,
but when actually my models consists of, let's say, 20 components each, all having different, so I want to train on 50 models, then I end up with 1000 components, which I have to label first.
Yeah.
And also, okay. Right.
Yeah.
So I need to label this first. All the components I need to be labeled. Then the H3D is created, and then it's effective in recognizing the pattern.
Yeah.
There's no way
not now.
I can label data.
No, we cannot label data. So in the next release 24.1, hopefully they will release it. It's actually in we are working on it right now to actually directly read the thickness and the material from the H3D or from the input deck. So I'm not sure what method they're using, but at the moment right now, we cannot directly read the thickness and material cuts. In the future release, yes, we can do that. So this is, you only need to rename if you plan to use the material and thickness as a variable. Otherwise, if you're dealing with mostly solid parts, right? So you don't need to do that.
Okay. We rename the component to thickness, material, and load amount, right? That is the inputs.
Load amount, yes, if you have different load amounts for different HVD.
Yes.
Otherwise, then you don't need to rename that as well.
Okay.
So that's this CA part label here. So you can use this like a workaround to input anything into the component name. Okay. Then this is for recognizing the shape by detecting the number of nodes there. Okay.
How about if one component consists of many thicknesses?
One component then then there's no way to do that because we can only have one component right now.
Okay. Okay.
Yeah. So you would probably need, like for example, then you can just use like a model name. For example, this is a variant A. You won't be able to see the thickness, but you can know that this is like a modular design that has this thickness. So this one we will not be able to reflect it, but at least you will know that this model A is causing these results. So you can rename your component. That will depend on your component name then, rather than the varying thickness. So you will need to change the component name in order for it to recognize as a different component.
Okay.
Okay. So that's the input and the output. So output, you can see here, input, you can choose both together. Output, you can only choose one at a time. Okay. So meaning to say you are training the physicsAI model one at a time to predict one result. For example, now I'm going to predict, let's say, the pressure results, right? So that's fine. Then let's say if I want another model to predict velocity, I need to retrain again. Okay. So this is predicting one result at a time. Okay. Then next here at the bottom here, these are the hyperparameters. Okay, so when you hover your mouse above them, you will see a short description of what those hyperparameters are. Okay, so the most important one is the width, the depth, and also the epochs here. Okay, epochs. The rest you can just leave as default. The batch size, if you have a lot of data, then you can use batch size here. Otherwise, you can just set as default as well. Right. So the most important is width, depth, and epochs. And what are they? Right. So let me jump to here. Okay, so this is physicsAI is actually based on deep learning, right? So deep learning at the zero layer here, this is what we call the zero layer, the starting layer. It has a few variables, right? So your entire, remember earlier we used the coordinates as a variable. So the coordinates will be distributed into all these variables here, right? N number of variables. So this N number of variables is what we define as the width. Okay, so the more width that you have, the more variables, the starting variables you will have. Okay, and then because this is a neural network or deep learning, you can see that you will have a second layer, and then it goes on to a third layer and so on. Okay, so in the end, you have one final result. In this case, is my pressure. Okay, so this is my pressure results. And here is what you call the depth. Okay, so these are the two parameters. So this is the width, and then this is the depth, right? And the width and the depth will tell you the entire size of your AI model or the entire size of the deep learning model. Okay, so the bigger it is, the more complex your physicsAI model is going to be, right? The width here, if you do not know a number, you can just use the default first. What I normally do is I always use the default, and then I will increase. So as I increase the number of width here, my model can get more accurate, right? But increasing the width also means that it takes longer to actually come up with the final solution, right? So it depends on the CPU resource that you have, okay? Depth here as well. Normally, if you're running on just your CPU, right, I would recommend probably just go 0 to 3. Okay, the depth here 0 to 3, right? So for example, yes, so this is 0 layer, 1 and a 2 and a 3. Okay, so this is good. But if you are, let's say, putting a higher depth here, then you will need to use GPU already because it will take quite a while to solve it. Right, so quite a while to train the model. So it depends on the computer resource that you have. Okay, it is possible to run GPU on your laptop. So like for example, this is my laptop. When I run this, I have GPU. I've already enabled GPU. So by installing two files, right? Basically the NVIDIA CUDA and also NVIDIA CUDNN, right? I'll put it in the chat. So to enable GPU, you will need CUDA. I think it's version 11. Okay, and then CUDNN version 8.7. Yeah, so you need these two. In order, you need to install both of them. The drivers can be obtained from the NVIDIA website. Just download it, install, and then you will enable GPU already. Yeah. So remember the width and the depth. So then the other hyperparameter here is epochs, right? Epochs is number of iterations. The higher the number of epochs, the more accurate your model is going to be. Okay, so again, you can just stick with the default first. But for this webinar here, I'm just going to use it 10. So we don't recommend 10. You can see that our minimum, we at least need 500 epochs. So I'm just going to use 10 for now so that it solves faster. So once you set all these here, you can hit train. Oh, sorry, you need to put a name as well. So normally I'll put what I'm going to predict has the model name. Otherwise, I do not know it's going to predict what. So pressure, and then just train here. Okay. So once you train, then this will then start model training. When it's running, then you can show log. Okay. So this is how physicsAI is starting. This is the log file. You can also show the loss curve to see how the accuracy or whether the convergence is achieved. Okay. Right. So you can see it's training. You can see there's a warning here. There is no validation being done. Okay, there's no cross-validation being done because we have less than 15 training samples, right? So unless you have 15 training samples and above, then cross-validation will take place. Otherwise, there's no cross-validation happening during the training. You can see a number of epochs, iterations, 1 to 10, you train. You can see the loss curve here is basically how we measure the accuracy. The lower the loss curve, the better it is, right? So you can see that it's going down. Of course, I need train for 10 cycles, so it's actually not very accurate. But if you train more, let's say you take the default of 1,500, you get a better model here. So you can see that it's going down, you then achieve close to zero loss here. Okay. Now, when I'm running with GPU, you can see that there will be a report on peak GPU usage. If you don't have GPU enabled, then you won't see this one. You just see the total training time here. Okay. So that's the successful training of the model. You will see it being shown as done here. Okay. So
Excuse
when
me,
Yes.
Ramon, can we specify loss as a target?
No.
No.
You will just
okay.
you will just
Just only the epochs.
Yeah, you epoch until it finish everything, or if it achieve a convergence. So there's a patience here that you can achieve convergence. Here means that it will only achieve convergence after 500 steps. So it wouldn't stop so early as well. But early stopping is enabled. So that means when it's achieved convergence, it will stop by itself.
Okay, thank you.
So that's the training side. When it's done, you can then go to model testing. So you just hit plus. I'm going to test the pressure model that I've trained on now the test data set. Okay, click OK. Then it will test. Remember, my test data set has 2 models. So it will test the AI model on both. And then you represent the score there. We are using the mean absolute error. So it's the error of every node in the model, right, versus the original true results from the solver, and then being averaged out. So you can see here the contour MAE. If you want to see what MAE is, you can look at the detailed report. You can see this is actually all the errors that we actually measure. Okay, so the entire report will show you all this. I can see for a run, all right? And yeah, once you, of course, see the error means that in this case, I'm predicting pressure, right? So pressure, maybe my model here, my pressure is in the unit of Pascal. When I see here contour mean average error means that it is 292 Pascal of difference, okay, between the true result, which is from the solver, and this predicted result here. So of course, this result cannot be trusted. I need to train the model for 10 cycles. So I definitely need to train more. But yeah, this is basically how we read whether this is accurate or not, right? So here we just take it as absolute here. And you click on show results. This will open 2 more windows here. It compares the AI predicted results, right? So this is predicted with the pressure model that I trained with the original results, the true results here. Okay. So yeah, so don't take this as the final result, because I need to train this for 10 cycles. But you can see roughly where are the higher pressure and where are the lower pressure and so on. Okay. So even look at the next test data. This is the first one, this is the second one. Just hit show results and then you load the second model. Right. So here is how you actually check and see that whether your physicsAI model is accurate or not. If you're confident already, then you can actually use it. So how to use it? In your model training here, just set this as active model. All right, so this is an active model. Okay, so now this is already an active model. And when it's already active model, you just need to drag the new design in. So I have two files, but it's actually the same design. You can either use a mesh model, .fem here is a mesh OptiStruct model, or this is just a CAD file, right? It's a parasolid file. Just drag it in to HyperMesh, right?
So this is sorry, Raymond, but this is a complete new one, right? That we haven't simulated.
Yeah,
this CAD
this
model.
is completely new design. You have no result for this one. Like the designer just designed this and asked you to validate. You just drag into your HyperMesh here, hit predict, and then this will then predict the results of this design based on the model that you have set as the active model in the model training here. Yeah.
Do we need to do any definition on the metadata of solid model for recognizing the inlet, outlet, and
No,
balls?
no need. No need, no need. There's no need
Okay.
to. Yeah. So this is how prediction is done on the geometry. It works the same for mesh as well. So if you already have a mesh model here, for example, here this is already mesh model. Okay. And then you hit predict again. This will then predict on the mesh model also.
Is predicting on map model is more accurate than geometry model?
There is right now there is influence in the mesh, but I would say that it is more important that you are using the right data set for training rather than predicting here. So if you already have a good model, right? In this case here, my model is not good. If you already have a good model, then you don't have to worry too much about the mesh, right?
Okay.
Training the AI model here is more important rather than meshing your model and then use it for prediction.
And how do the algorithm know that the model that we input have how much load amount?
You wouldn't know. You wouldn't know. So that's why I wouldn't recommend load amount for now, because there is no way that the AI model will know. So it is okay for thickness and so on, but it is not ready yet for loading. Yeah, unless it's unless the boundary condition is constraints, then it's okay. Because for constraints, basically it will actually show in the model itself. For example, if there's a bolt hole, there will be a hole there. So in that case, it's okay. So boundary conditions that are caused by a change of geometry, then it is fine. But if boundary condition that is purely just a magnitude, then it's harder to predict actually. In the new version, we can actually we can create our own outputs as well. So that will be easier to be dealt there. Right now, you have a lot of changing magnitudes in your model.
Yes, we have the thickness variable and load amount variable that we want to change in the model.
So I would recommend maybe you can try, I've not tested this one, but try to rename your parts first and also include it in a component name as well.
Okay.
So yeah, we can work together on this one, see how we can actually get it to predict the actual loading that you want.
Excuse me, Raman.
Yeah.
Now I see that the predict result is not trustable, and I would like to add more training samples. How to add the training sample?
So let's say you need to add more, so you just need to read in the new data set, right? And then you can then retrain. Okay. So
Okay. It will include the previous data that already trained, or I need to retain the entire stuff?
No, you will use back the same project here.
Okay.
And just feed in your new data, and then just train on the new data. So you don't see this right now, because it's already hidden. We need to enable it. You actually need to set this up in the system environment variable. So I will send you that later on. Once you enable that, you will see there's an option to what we call transfer learning. So you can actually train the AI model again on new data to make it more accurate.
Okay, thank you. Yep.
Yeah. Okay, so once this is already done, right, you don't need to save, right? So if I close this directly, how do I reopen it? Okay, so that's why it's important that you know where you save your working directory. It is always in here. So look for your working directory. You have all these different folders here, and then there's one file called the ps_proj. So this is the project file. Okay, so let's say if I've closed everything, let me do a new session. Okay, so let's say I have a new session. I want to read back my model just now, or I want to reuse this, or if I pass this to someone else, how does it open it? So just go and look for the ps_proj. So for the ps_proj, read it in, and then everything will be read back in. Okay, so then the next person or you yourself the next day can just reuse it. Okay, everything will be read in again. Okay. So remember this, I will pass the entire folder instead of just passing this file, because this will then refer to all the data inside as well. Okay. So the trained model is actually saved as this PS model here, right? PS model. So yeah, I will pass the entire folder instead of passing just the ps_proj. So basically, this is how we can use physicsAI to train. So once it's already trained, you can see that when I hit predict, I immediately get the results. So it's in a way it can replace your solver if your AI model is accurate enough, right? So it all depends on how accurate you can actually get your physicsAI model. And accuracy, it is not just based on the hyperparameters that you set here. It is actually based more on the models that you use, right? So the more data that you have, better the prediction is going to be. Okay, and also take a look at your data set and see if there's also any outliers or not. Means that there are some certain results that are causing it to vary a lot. Then probably going to exclude those as a data set. Okay. At the moment, we can use physicsAI to train for linear, non-linear, right? Transient as well. But important to take note that if you are training on non-linear and transient, you need to make sure that the time step or the number of outputs for each of your H3D is going to be the same. For example, my first H3D has 10 outputs because I have 10 time steps. The second H3D has 20 outputs because of 20 time steps. You cannot use this together. It needs to have the same outputs. Okay, so 10 time step in the first file, 10 time step in the second file, and so on. So take note of that if you're going to train on transient or on a non-linear static.